in this video, let us now talk about the histology of the dermis and the sensory structures. Okay, so the dermis is the connective tissue layer which supports the epidermis. You can see it here, just deep to the epidermis. So the dermis, as we said, it is separated from the epidermis by a basement membrane, and the cells of the epidermis are attached to that basement membrane by hemidesmosomes. Okay, so these projections of the epidermis into the dermis, we said they are called epidermal pegs, and the extensions of the dermis into the epidermis, they are called dermal papilla. So remember, we said this help to hold the epidermis to the dermis. So the dermis is mainly composed of two layers whose boundary is not clearly seen. So the first layer is the papillary layer, which is the superficial, this one, and then the second layer is the reticular layer, which is the deep layer. Okay, so let's now look in closer detail. The papillary layer, this one we said is the superficial layer, and usually it's thin. All right, so it is mainly made up of collagen fibers, which are thin and are mainly of type 1 and type 3 collagen. Okay, so this layer is mainly cellular, meaning to say that it contains more cells as compared to the reticular layer. So the papillary layer, remember we said it is connective tissue, so there's loose connective tissue, and the usual elements of connective tissue, which includes cells like fibroblasts, mast cells, dendritic cells, and also leukocytes. We also find blood vessels and nerve processes within this papillary dermis, and then the nerve processes, they either end in the dermal papilla or they penetrate the basement membrane into the epidermis as the free nerve endings, which will act as sensory structures. For the reticular dermis, this is the deeper layer. All right, we can see it here. So say this is the boundary. Remember, I've said the boundary is not distinct, but let's just assume this is the boundary. We see much more thicker collagen fibers down here. So this region is much more denser connective tissue as compared to the papillary layer. Therefore, we have thicker fibers, mainly type 1 collagen. So the reticular dermis is mainly classified as being more fibrous compared to the papillary layer. All right. We also find reticular fibers and elastic fibers within the reticular dermis. So it's termed reticular because we find reticular fibers within. And the elastic fibers, they act to provide elasticity to the skin. All right. So in older people, their skin develops those wrinkles because the elastic fibers and the collagen fibers have thickened, so the skin loses its elasticity. Now let's look at the vascular plexuses that can be found within the dermis. So first of all, we have the subpapillary plexus, which is located between the papillary and the reticular layers of the dermis. Okay, so this subpapillary plexus will give branches or smaller vessels which will go into the dermal papilla and form a fine network of capillaries which supplies the epidermis. So nutrients diffuse from these capillaries through the basement membrane into the epidermis and supply cells of the epidermis. Alright. Then secondly, we have a deep vascular plexus, which is located much deeper in the reticular dermis, almost nearer to the junction of the reticular dermis and the hypodermis. Right. This one is much larger blood and lymph vessels. And between these two vascular plexuses, we find what you call arteriovenous anastomosis or arteriovenous shunts. So these anastomosis are there to regulate the temperature of the body. Right. When body temperature is too high, the arteriovenous anastomosis or the arteriovenous shunts dilate so as to increase blood flow and hence increasing the heat loss from the skin. And if the body temperature is low, the chance they will constrict so as to reduce the blood flow and reducing the heat loss to the surroundings. Okay, that's how the arteriovenous anastomosis work in thermoregulation. Let me talk a little about the hypodermis. Okay, so the hypodermis, we do not consider it part of the integumentary system, but however it lies deep to the dermis. Okay, so it is mainly composed of loose connective tissue, mainly filled with adipocytes. So we'll find that some of the structures in the dermis will end or will be located in the hypodermis as well. For example, with Pacinian corpuscles, we have the roots of hair follicles that are located within the hypodermis as well. Alright, so this dermis is there to attach the skin to the adjacent organs and muscles. Alright, so it also allows the skin to glide over the organs. Okay, so that's all about the hypodermis for now. Now let's talk about the clinicals. So we have what you call stria, or we may refer to it as stretch marks. Alright, so this is a result of the tearing of the dermis, and it presents as these lines. Alright, this is tearing of the dermis. Alright, it can be due to a rapid weight gain. Aging is all about the skin losing its elasticity because the elastic fibers become rigid and tense. Okay, as for tattoos, the ink which is used during making a tattoo on the human skin, it collects in the dermis. Alright, so it is applied on the skin surface, then it moves through the epidermis, through the basement membrane, and collects in the dermis and into the blood vessels and lymphatic vessels of the dermis. So that is why tattoos become permanent, because this ink is now present within the blood vessels of the dermis. Okay, now let us talk about sensory structures which we find within the skin. So we have two classifications of sensory structures. First, we have what we call encapsulated sensory structures, which are those covered by a sheath, either melanin, which is produced by Schwann cells, or collagenous sheath. Alright. Then unencapsulated are the ones without any sheath. So for the encapsulated, we have what you call Meissner corpuscles, Pacinian corpuscles, the Krauss end bulbs, and the Raffini corpuscles. Alright. And for unencapsulated sensory structures, we have Merkel cells, free nerve endings, and the root hair plexus. Alright, so these sensory structures, you'll find them, some will find them in the epidermis, and some will find them in the dermis. So it depends on which one. Alright, so let's start with the Merkel cell. This one is located within the stratum basale. Remember, in the epidermis, the most basal layer, the stratum basale. Okay, and these cells, they sense gentle touch, so we refer to them as tactile receptors. Okay, so each Merkel cell has these little cytoplasmic projections which sense the tactile stimuli and convert. So the cell now converts the stimuli energy into an electrical impulse, which is picked up by this expanded terminal part of the axon. So this is the expanded terminal part of the axon which picks up this electrical impulse and conveys it to the central nervous system for recognition. Free nerve endings are located within the dermis, but however, they can penetrate through the basement membrane and enter into the epidermis, where they will function as either thermoreceptors, pain receptors, tactile receptors, and they also sense itching. All right. So you can see them here in this picture. Our free nerve endings within these ones are within the epidermis, and some are within the dermis. All right. The root hair plexus is located at the base of the hair follicle, and this one, it sends hair movement. All right. So this is our root hair plexus at the base of the hair follicle, sensing the movement of the hairs. All right. So they are mainly located within the reticular dermis because that's where we find our root hairs. Now, Meissner's corpuscles, these are tactile receptors again, but they sense light touch. All right. They are found within the dermal invaginations into the epidermis, or what we normally refer to as the dermal papilla. All right, these ones. So our Merkel cells with their elliptical structures, as you can see in this picture, elliptical structures consisting of wound up sensory axons and flattened Schwann cells. Right. So our Meissner's corpuscles, they are more numerous in the soles, the palms, and the fingertips. So these ones are associated with recognition of the texture of an object. That's where we mainly find them, in the soles, palms, and fingertips. Right. Bassinian corpuscles are lamellated corpuscles or encapsulated corpuscles. Right. You can see here they are oval structures located within the reticular dermis, and they can also be found in the hypodermis. So this one is in the hypodermis due to the presence of this adipose tissue. We can conclude it's in the hypodermis. All right. So they sense, cause, touch, pressure, and vibrations. Okay. Krause end bulbs. These are simple encapsulated ovoid sensory structures mainly found in the skin of the penis and the clitoris, where they sense low frequency vibrations. All right. And lastly, the Raffini corpuscles, these sense stretch and twist. Okay. So that's the end of this presentation on sensory structures.